Hi, and welcome to step 2 of project 6. That's the project, if you recall, where we're creating SVG output by using functions in C. And I'm going to recap a little bit with some of the stuff that's in the step 1 video, but you need to watch the step 1 video first. And then we'll go ahead and finish up the remainder of the stuff you need to do to complete the project. So we're here on the step 2 video. And we're going to create, in step 1, we found an SVG feature to play with. I found that down pointing chevron or arrow, but you can find lots of other stuff. There's a list of possible SVG features that you can find in the assignment. So there's a whole list of them. And we did that. We tested that feature out on the W3 Schools try it page and showed that it worked and did what we wanted. And this is maybe the tricky part so far, formatted that SVG feature for use in C. If you recall, what that involves is breaking up the big long SVG text line into multiple lines and then putting quotes around it in such a way that all the quotes inside a string are single quotes and the entire string is double quoted. That's what C needs to see in order for you to use that string in your function. So we'll pick up there. We'll take a look at that string again. That's basically where we wrapped up. You were posting that string in the discussion forum, along with some suggestions, some ideas you have about which parameters might make sense. What entities in that SVG, usually numbers, but it might be colors, would make sense to make parameters to your function so that when you use your function more than once, then you can change the location or the color or some other attribute of the SVG by changing the parameters you pass to the function in C. And of course, you put the function in the loop, give it random numbers, and get all kinds of stuff. In this video, we're going to create the basic C function to print string. I think I did a little bit of that in the first video, so you'll see that the very rough outline of the function is there with the SVG CI'd SVG string pasted into it. Then we'll test that function once we get it working. We'll add parameters to the function, and then we'll maybe enhance the function to show you how you could add some additional parameters and work them into the SVG to make it a little more flexible and entertaining, if you like. So that's what we're going to do. Let's look at the code again. That we have for SVG creator start.c. Remember, this is the original SVG creator program or a version of it that you used in project 5. This one draws a circle, but we added to it the beginning of a function definition. So above main, it's important to do it above main because this saves you a great deal of difficulty with what are called function prototypes. So if the compiler can see your function definition before your function is used, and your function is used in main, then that just makes things easier because it knows what to expect and doesn't give you a bunch of warnings. So I called my function down angle to sort of suggest what that SVG feature is. Maybe not the greatest name. Notice right now it's void, returns nothing, because it's going to do output. It's going to do a printf, but there's really no value that's being returned to be used in subsequent code. So that makes it a void function as opposed to a function that returns, say, an int or a char star. Functions don't have to return a value in C. They can, and they often do, but they don't have to. It takes currently no parameters. That's what the empty parentheses mean. They must be there even though they're empty, because that's what tells C that this is a function and not a variable, by the way. So inside that, all we have so far is a variable called a character pointer called our shape. And that's initialized to all that SVG that we pulled off the web, carefully quoted, and stuck in our program. So if we refer to the variable our shape in this function, we get all this stuff. One really simple way to test this function is to just put a printf in here. Don't have any parameters yet. Let's just see if the function runs and spits out, I think it's like a black down pointing arrow in the purple screen, right? Because we're not changing the location or the size or the color. To do that, printf. And all we really need to printf is this string called our shape. So far. Now, when we have additional parameters added to the function definition, we're going to end up putting those down here in the printf so that they'll get substituted in and they'll change the string before it gets printed out. But for right now, this should be fine. I'm going to save this and compile it. You may recall that I'm doing the compiling the kind of old school way because my IDE is sort of broken, but it works fine. So I'm going to use GCC at the command line to compile this file and see if there's any syntax errors so far, right? So to do that, I've already got that command stored in my command buffer from the previous video. So I'm just going to run that GCC command. And it looks like I made a mistake. Let's figure out what I did wrong. So format string is not a string literal, potentially insecure. That's probably true. And treat the string as an argument to avoid this. Printf. Okay. Okay. We could try that. It wants us to do this for basically security reasons. It wants us to say, this is a string, print this string. So let's see if that fixes the error. So remember, printf wants a format string and then a series of 0 or more variables, usually 1 or more, that are quantities that get substituted into the output according to the placeholders like %d, %s, and so forth and so on. I guess we could put a new line at the end just for tidiness. That's not required. And let's see if that does better. Oops. We got in the right window. Well, compiled, always a good sign. If it doesn't compile, it won't run. Even if it does compile, it may not run. If it does run, it may not be correct. You know that sequence. Okay, let's run the program and see the output, which will probably still be, it should be our circle. Well, no, it won't be any, watch, it won't be anything yet. We get the right one. There. SVG creator start. No.c. The .c is the source, and the one with no.c is the output. Got to be careful there. Don't clobber your C file with your output file. Let's run this. That looks like the same old circle. Why do we not see the printf? That's a rhetorical question, but you should ask yourself that question. Maybe it's because we defined the function, but we haven't called it or used it yet. That is exactly why. So let's invoke the run, call, execute, the down angle function down here in main. So there's circle. We ran circle. That's why you see the circle SVG. To run this function, it's down angle. And right now we have no parameters. So it's kind of a boring function to type, but that should spit out a whole bunch more SVG. Because now we're actually running the function, which will cause that printf to run, which will cause the printf to print out a whole bunch of stuff. So I got to compile it again because I changed it. I think I called it .hold, so let me fix that. I'm going to rename the output file this way. So compile it. Okay. Now if I run this program, this is why doing it in the IDE is probably easier than doing it on the command line. Command line, you have to keep track of names of things, but it's not like rocket science. Okay, a lot more SVG this time, as should happen. And let's just grab this stuff. We'll test it as we always do in the W3 Schools Try It editor. And let me rearrange my windows a little bit here. So replace what's there with what we just created. And I must have pasted it in the wrong place. So let's do this right. Or I copied wrong. Let's see what I copied. Might have copied the wrong stuff. We will be available to avoid this copy and pasting at some point in the future in our class when we talk about files and how to write to files and how to read files. But not having talked about that yet, the copy and paste we're doing here is clunky, but it will work. Yeah, I copied way too much stuff. Here's where I want to start copying. Copy this down to here. Put that in the Try It editor. Wherever I put the Try It editor. It's probably under my, yeah, here we go. Okay, and if you look, you'll see here's the circle code from the circle, the output of the circle function, and here's the code for the down arrow, or whatever we're calling that thing. Okay, let's run it. We have both shapes because now we're actually running the function. So that's a start, but of course, if we run this function 10 times, we're going to get exactly the same thing every time. In fact, it's not going to look any different. Maybe you even did this in project 5. It's just going to drop 10 versions of this shape on top of one another. So it won't look any different at all. In order to make it look different, we have to be able to move the shape around so it's not lying always on top of itself. And we probably want to change the color unless you're really enamored of the purple and black scheme, which is fine. That also gives us 3 parameters, right? X, Y, and color. X and Y are going to be, you're going to see a pretty straightforward way to do those. Let's actually go back and look at the SVG. If we were to replace this hard-coded 512 and 512 with a different number, we should be able to get a different size, different height and width of this shape. Let's try that. Again, go back to the C code. Here, go to the function definition. We'll have to change the run to. Now we need to add 2 parameters. Those probably need to be ints because you're just talking about whole numbers of height and width. Probably they could be floats, and SVG is so smart you can put something at 0.5, but let's not do that. Let's just do an X, int, Y, actually height and width. Int height, well, that was unnecessarily complicated typing. Okay, here instead of 512 px, px is for pixels. I think you can even leave it off and it'll still work, but I'll leave it. I'm going to put the printf formatting character for an integer, which I'm sure you all know is either %i or %d, your choice. And here for the height, I'm going to put another %d. And the px should get ignored. So what's going to happen when, if I typed it right, %d, when printf runs, it's going to substitute in whatever we pass for width to that first %d. So if you pass 10, it's going to say 10 px. It's going to put whatever we put in width, the second parameter, in here. So now to use that function, if you just, you did this now, you changed the definition, but you didn't change the call, what do you think will happen? Let's find out. So I'll try to compile it. I think it's going to be a compile. I think it's going to be a compile error. And it sure is. And the error is actually intelligible. Not all compiler errors are intelligible. This one says too few arguments to function call. Expected 2, height and width, got 0. Oh yeah. If we look down here in main, sure enough, empty parentheses. So let's try putting a height of, I don't know, 100 and a width of 200. See what happens. Now, I'm not absolutely sure what will happen. I think it will get bigger. I hope it will get bigger, but let's find out. There's a large amount of trial and error in getting things to look the way you want. The rules of C are very clear. The way the compiler counts parameters, matches types, that's all very rigid. What the SVG you spit out looks like is very flexible and requires a lot of experimentation. All right, let's compile it again, make sure it compiles now. And it does. So let's run it and grab what came out of it. Oh, well, no, there's still something missing, isn't there? Look at this. Height equals 1,000, width equals, that's the circle. Ah, still got the %D in there. Why is that? Let's look and see. Probably because in the printf, I forgot, if you want printf to substitute something for a formatting character, you must provide that argument to printf. So I got to provide, the first one is width, and the second one is height. If I could spell height. GHT. Notice that they don't have to be in the same order. Up here, they're height and width when we pass them. Down here, we're calling printf with width and height. All that counts is that whatever is here in the first one is going to match the first %D, and whatever's in the second one is going to match the second %D, and the %S matches this whole mess. So let's try that. So we saved it. Let's try compiling that. It should compile. What's my warning? Data argument not used by format string. %S in width. So hang on. Okay, after a moment's thought, which I spared you, I think what we need to do is get rid of this, because now our shape already has it already has the formatting characters in it, so we don't need the %S. So I believe that this will compile, and let's find out. It compiles. Okay, so that's actually, so what that statement says, just to review, since that was confusing me, probably confusing you, printf is going to print the following things. Our shape. It's going to go and find this character star here, and it's going to process this string from left to right, and everywhere it sees a % character, it's going to substitute in the next argument. So it's going to put width in here, replacing %dpx. It's going to put height in here, replacing %dpx, yeah. So let's try running this program and see what we get. Okay, I'm going to paste it in, then we'll check it and see what we get. So we're going into the try it editor, as we did before. Get rid of what's there now. Paste in what's in here. And sure enough, I think this worked, because there's the width. The first one is the circle, which we know that works. And the second SVG is now 200 and 100. Where did the 200 and 100 come from? They came from the arguments we passed to the function in main. So here's the proof. Let's run it. Yeah, it's a lot smaller. So we found a way to resize the shape by using parameters arguments, passing them to our function, we can change the size of the shape. And we can also do the same thing if we want to change the color or if we want to change the position. Now, when you look at this SVG, it doesn't actually give a position. Circle had CX and CY, but our shape down here, the down pointing arrow, does not have a X and Y, but that's easily remedied. We can just add that SVG to the printf, to the string in our function, and then we'll have it. The same way we can add fill equals, which is how the circle got its yellow color. So let's do that. Let's do the color first because it's really pretty easy. Let's add a color parameter. We can add it down here. As long as you do it both places, it doesn't matter what order you do it in. And you can also give names for colors. So red. I'm not very creative. Let's use red. You can also give RGB in a series in a parenthesized list of 3 numbers, as you remember from Project 5. But there's also some predefined color names like red, yellow, blue, green, probably some other colors. Now, having added that parameter up there, we've got to add it here. Since it consists of a string of characters, it must be a char star. We'll call it color here. Name here does not have to match anything down here, but we need to insert that. And to make this color work here, let's just insert another line which says fill equals %s. %s should get the word red substituted in to make a complete piece of SQL. So let's try that. Color. And if we look back at the example of circle as our model here, that's got a very complicated fill. Let's look at the simple one. Yeah, fill equals something. And that's inside in this case, inside the SVG. So we should be okay. So we're down here to, and I better put a space here so it doesn't run directly into the next word when this all gets strung out into one string. Let's see if this compiles. It should. It does. Let's run it. And let's take the resulting HTML and test it out in the W3 Schools Try It editor. And looking at it, I was just going to put an extra blank line here. SVG does not care about blank lines. Neither does C. 200 by 100, fill equals red. Let's see if that works. Sure enough, it's red. Okay, we now have 3 parameters. And you could quit at this point if you wanted. Not quit, but you could say, this is my function, and here's the source code for my function, which you're going to post. Here's comments. I'll show you in a minute how that looks to get so folks will know what your parameters do, because just in looking at the code, they may not be obvious what's happening, especially if you named your parameters I, J, K, and L or something kind of crazy like that. So we'll come back to that. So that's working. So I have 3 parameters. If I wanted to make it so that it could go to it could move to different locations, I think I just need to do X and Y. So I think I can add here. Again, it doesn't care much about white space either. Space and add. Wow, we're going to end up with 5 parameters. That's cool. An int X, an int Y, And down here in the printf, of course, once you get the hang of modifying the stuff, it goes pretty fast because you see the connection, which is what really is to be learned here, between the formal parameters, as they're called here in the function definition. Those are the ones with the type names preceding them, and the invocation of the function, the actual parameters that are passed down here when you call it. So having added those two, let's put this thing at 350. I don't know how big that's going to fit on the canvas, I think, so we should be fine. Save that. So now we have 1, 2, 3, 4, 1, 2, 3, 4, if I can count, 5 actual parameters matching, hopefully. 5, 1, 2, 3, 4, 1, 2, 3, 4, 5 formal parameters. And the parameters have to match in terms of the number of them. You can't have fewer, you can't have more in the actual arguments than you have in the formal parameters. And they got to match in type. Whatever you pass down here has got to match the type that you're expecting up here. You can't pass a char star for an int. You can't pass an int for a char star, so forth. You can't pass a float for an int, so forth and so on. Let's compile this. Hopefully it'll compile. Compiled, good sign. And let's run it. And let's grab the data beginning here. Paste that in the try it editor. And run it. Yeah, it's down in the right corner now. Cool. That means if we do one more thing, no more parameters, we've got enough parameters, we could go to main, put a loop around that function, and fill the screen with little down pointing arrows if we wanted. Because once you make a function, then you can use it over and over again. In fact, that's the only reason to make a function. Why go to all that trouble of having the parameters and matching them up if you're not going to use it more than once? If you're only going to use it once, although it's kind of tidy to put in a function, you really could just drop it all in main, right? I've seen lots of programs like that. They're stylistically bad because they're hard to maintain because it's like a wall of code, but that will work. So if we go back here, and just to show how it works, and you did this in project 5, but we'll do it again here. I don't know what this will look like. I'm just doing this extemporaneously. For, and you know this incantation, int I equal get 0, I less than, let's don't do a whole lot of them. Let's do 10, I plus plus. So we're going to count 10 of these features. And inside the function, inside the loop, we're going to put this function here. And we're going to replace some of the constants here, like the x and y. Let's replace them with values from the loop, like I times 50 and I times, you probably did this in project 5, times 70. Sounds good. So we should get a lot of shapes this time. We only had to type the function once. We only had to type the argument list once. But because it's in a loop and it's being repeated, that code, all that code gets run over and over again. One of the convenient ways that functions make your code shorter and easier to understand. Okay, let's compile it. Didn't mess up the loop, that's good. Let's run it. Should be a lot more output this time. Yeah, it is. There's a wall of text, but even we can fix that with some new lines, by the way. It looks more intimidating than it really is because it doesn't have much white space, but that's easy to fix. But let's see what it looks like in a try it editor. Here we go. And run it. Wow, little down pointing arrows all over the place. So you see how this works, right? This is a model of creating and using a function. And in this case, the function that you create will be different because you'll have a different shape. And maybe the way you use it, the parameters you choose may be different from the ones I chose. The way you use it in main, the way you call it or run it or use it is probably going to be different. But the big idea is the same. So the last piece is, so you could post this code, which contains, let's say, your function and an example of using your function in the discussion forum. But you need one more thing. Just looking at the function, if you just look at this part, what do those numbers mean? Now, you and I probably remember because we just typed them. But if you come back to this function in 2 weeks, or someone else picks this function up and tries to use it, as they will in step 3, they're not going to know which number's which one's width and which one's height, and which one's X and which one's Y. Let's put comments in the code to say what's what. And that looks like this. I've already done that here to make it a little easier to see. Here's what I did. I put comments in and I said what it does, draws a V feature. Okay. I put based on, and I put a URL to where I got the shape from. It's a nice thing to do because it is a Creative Commons license, and the only requirement for reusing stuff under Creative Commons is that you say where you got it. So we're fulfilling that. And then for the parameters, I explain what the parameters are. Wide, in order. Wide, how wide to make the feature. High, how high to make the feature. X, upper left-hand corner. Y, upper left corner in the vertical. Color. And the parameters in this example are in a different order, but the function works exactly the same way. So part of what you deliver, your code, your function that you paste in to the discussion forum should have a block of comments like this showing, documenting what each parameter to your function means. That's basically it for step 2. In step 3, you use your function. Heck, you've already used your function once in main to test it, and you use a function provided by another student, and you get their function to work along with your function in your code, and vice versa. So I think that part will be fun. I think the results will be really interesting. And of course, I remain available as always for questions, comments, whatever, in the discussion forums or via email. So I hope to see some interesting stuff on this, and I hope to hear from you soon.